Bismillahirrahmanirrahim. Ready? Okay, we have two questions here, inshallah. The first question here says, given BD bisects angle ABC. So we're given that segment BD. Okay, that's this over here. That one. That's a little bigger there. So that segment right here, BD, okay, is bisecting angle ABC. So that's this angle over here. Okay. All right. So let's write that down. So as soon as I see those, I mark the diagram, so that helps me kind of visualize it. So that's congruent to that. That's from definition of angle bisector. Okay, so angle bisector divides an angle into two equal angles, and then we're given that angle ADB. That's ADB. That's that angle. Maybe a different color. Given that this angle is congruent to CDB. CDB. Okay. And then we're asked to prove angle A is congruent to angle C right there. So that's what we're asked to prove. Well, how are we going to do that? Well, if we can prove this triangle to be congruent to this triangle, right? Then we can prove angle A is congruent to angle C, right? From CPCTC. So my goal is to prove that those two angles are congruent. So those two triangles are congruent. So I can prove those two angles to be congruent. Okay. So how am I going to do it? Okay. Any ideas? Okay. Well, I think you probably figured this one out, inshallah. So, but if you didn't, this is how I think I would do it. Okay, I have angle, now angle. I'm not given much else, but I do know this side is congruent to itself. That's from reflexive property. Then I have angle, side angle. There we go. So I have angle, side angle. Now I have those two triangles congruent. Then these by CPCTC, those two angles will be congruent. Okay, so there we have that proof. If you were to write a proof for this like this, and this is how it would look, at least the way I did it. First we had stated BD bisects angle ABC. That was given, and from there we concluded that angle ABD, that's this one over here, was congruent to CBD, that's that one over there. That's from definition of angle bisector. Then we had said ADB is congruent to CDB. That's this angle and that angle. That was given to us. And then I said BD is congruent to itself from reflexive property of congruence for segments. And then we equated the two triangles congruent. ABD, CBD. It's important to write them in proper order. That's from angle, side angle. And then we said angle A is congruent to angle C from CPCTC. Congruent parts of congruent triangles are congruent. And we said QED, quod erat demonstrandum, which is Latin apparently for, and that is which was meant to be proved or required to be proved. And sometimes you can write this at the end of the proof. It's kind of fun to say, yeah, QED. Quod erat demonstrandum. That is which was required to be proved. Okay, let's do this next one. Here we're given the picture, and there's certain things that you can assume from picture, certain things that you can't, as you recall. But here we're given this picture, and I stands out right there. Boom! I got right angles. That helps. Okay. So I'm thinking HL, but I see. Okay, and then we're given that 7 and 7. That means ABC is congruent to CD, basically is what that is saying. Okay, and then we're asked to prove that AB, which is this one over here, is congruent to ED, which is over here. So this is what we're asked to prove over here. Okay, so that's what we were asked to prove. Okay, so I have the same approach. If I could prove the triangle is congruent, then I got my CPCTC, right? So how can I prove? Okay, well, I have hypotenuse like as my recourse, right? And I start thinking, when I see a right triangle, I think, oh, okay, Pythagorean theorem, triplets, and and hypotenuse leg. Okay, so let's see if I could use the hypotenuse leg over here. So I have, this is the hypotenuse, but I'm not told that they're congruent. Okay, well, maybe I can somehow, but I'm given that these legs are equal length. Well, if they're equal length, that means they're congruent. That's the definition of congruence, that they're the same length. So I got the leg part, but I don't have the hypotenuse. And this is, well, somehow, okay, well, I'm not sure if I can use hypotenuse like that. Well, what else can I do? Well, what do you think? Okay, let's see. Think. Oh, I see vertical angles. Do you see vertical angles? Right there and there. No, I'm just kidding. That's not the vertical angle. Here's a vertical angle and here's a vertical angle. Vertical angles are congruent by vertical angle theorem. Oh, that's wonderful. Now I have more angles, right? Now let's see what I have here. I have angle, I have a side and angle. Oh, wow. So I have angle, side, angle, right? So I have angle, side, angle. And I could prove those two triangles congruent. After proving those two triangles congruent, then I can prove that AB is congruent. AB is congruent to DE from CPCTC, right? So from angle, side, angle, I get CPCTC, and I can prove those to be congruent, okay? Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.